Okay, welcome to Chapter 7, 11. Chapter 7, Lesson 7, Virtualization and Cloud Concepts. So let's get into it. As always, I talk about prerequisites that you should be familiar with before taking this course, as well as taking the chapters and the lessons, even though I use it interchangeably. Hopefully the videos also helps with these concepts. So again, I like to just always cover them and make sure you make note of them from that perspective. So you want to be very familiar with operating systems, computer hardware components, and general IT terminology. You want to have an understanding of basic network principles such as IP address, subnets, and basic network configuration. You want to have basic knowledge of virtualization concepts such as the various types. What is virtualization? Primary use cases. Be very familiar with cloud concepts, fundamentals, including cloud service models such as infrastructure as a service, platform as a software as a service, and development models such as public, private, hybrid clouds. You want to be comfortable using different operating systems, particularly Windows, Linux, as they're commonly virtualized environments. You want to have an understanding of basic security principles, best practices to secure both physical and virtual environments. That said, let's get into it. So, table of contents, I'm just going to really talk about client-side virtualization, and then I'm going to summarize cloud concepts in general. So, introduction, again, fundamental concepts of virtualization and cloud computing. Virtualization technologies have basically changed. They really changed the game, I like to say it, and how resources are managed and utilized. It's offering significant benefits, flexibility, scalability, efficiently, and cost. So cloud computing further extends these advantages, providing scalable services really over the internet from that perspective. So let's kind of get into it. So let's first talk about hypervisors. And hypervisors are that create and manage virtual machines, VMs, on a whole system. They enable multiple operating systems to run simultaneously on a single physical machine by basically parsing out the system resources. There are two types of hypervisors. There's type 1, which is considered bar-metal, which is installed directly on the hardware, providing high performance and efficiency. The other one is hosted, which runs on a conventional operating system suitable for desktop or lightweight server virtualization. Over here, you'll have an example of what a type 1 will look like, and then a type 2, which is embedded hosted embedded hypervisor. So the first one is one I talked about before. You have your server hardware, your operating system, your hypervisor, and then it's tying into your different IoT devices. I like to see you have your mobile phone, maybe your iPad, and your laptop. Then you have type 2. Again, you have the server, and then you have the hypervisor, which is then tied into your various other platforms. So again, the one difference you'll notice is just how it's installed and configured. From an exam perspective, just keep that in mind from that perspective. So what is it used for, right? So client-side virtualization enables users to run multiple virtual machines on their personal device. So it provides a way to test an application, run different operating system, or isolate work environments without requiring additional hardware. This method enhances users' productivity as well as system security by maintaining separate virtual environments. A good example is of one of my development days. If I wanted to spin up different operating systems just to see how my code would work, this would be a good example how I could spin up various Windows 3.1, etc., etc. So it allows me to experiment with different operating systems without necessarily having to have 10 or 20 devices with different operating systems running, for a good example. Now, if you talk about server-side virtualization, it consolidates multiple virtual servers onto a single physical server. The reason why this approach is good because it maximizes resources utilization. It reduces the hardware costs. It's going to simplify management. It's widely used in data centers, and that's really the key side of this, to enhance scalability, improve disaster recovery capabilities, and enhance better resource allocation. Again, just remember that from an exam perspective. When you think about application virtualization, it allows an application, as I said before, to run in isolated containers on a host of systems without direct installation. Now, this technology simplifies software deployment. It's going to reduce compatibility issues, which is key. It's going to enhance security by isolating applications from the underlying operating system. This is particularly useful for running legacy application on modern systems. So again, here's just an illustration that speaks to, you have the application, you have the client, you have the firewall, etc. from there. So container virtualization involves encapsulating applications and their dependencies into containers. Unlike traditional virtual machine, containers share the host OS kernel, making them lightweight and efficient. This approach ensures consistent network performance across a different environment. It streamlines the application deployment and enhances scalability. So again, this is just a machine virtualization where you have the infrastructure, the hypervisor, you have the guest OS, and the various systems from there. Both machine virtualization along with the containers. Okay, so when we think about the resources to effectively run these virtual machines, the host system must have sufficient resources. Again, CPU, multiple cores to handle current VMs, memory RAM, which is adequate memory for each VM to operate smoothly, storage, fast and large storage to accommodate VM images, robust network capabilities for VM communication. The requirements are as follows. Virtualization introduces several security considerations that must be addressed to ensure a secure and efficient virtualized environment. This chapter, this lesson is going to cover those essential security requirements, which is very important for virtualization. It's going to include what I like to call guest OS security, host security, and hypervisor security. So let's talk about guest OS security. Guest OS security involves protecting the operating system running within the virtual machine. It includes regular updates and patch management. It's going to use strong authentication mechanisms. It's going to ensure that the guest OS configurations follow best practice and security guidelines. It is critical to preventing vulnerabilities and attacks. Just remember that from that perspective. Host security. Now, the host security is going to focus on safeguarding the physical machine. Hosting the virtual environment, this includes hardening the basically the host operating system, monitoring for suspicious activity, and implementing robust access control. Maintaining the security of the host is vital, as any compromise can affect all virtual machines running on it. Please remember that. So looking at hypervisor security. So hypervisor security is critical as the hypervisor manages multiple machines on a host. It involves applying security patches, configuring security communication channels, limiting access to hypervisor, and ensuring that the hypervisor is secure. Is going to prevent unauthorized access, potential exploitation that could compromise the entire virtual environment. Again, just from a definition and concept perspective, here's an illustration of what that looks like. So now let's get into cloud security concepts. So you may know this, again, some of the prerequisites I talked about it, but again, I want to make sure I cover it from an exam perspective. So you have various characteristics. You have on-demand self-service. Users can access computing resources as needed without human intervention. Broad network access. So resources are available over the network and accessed through standard mechanism. Resource pooling provides resources are pooled to serve multiple customers. So again, providers resources are pooled to serve multiple customers. Rapid elasticity. Resources can be rapidly scaled up and down. Measured services. So cloud systems that automatically control and optimize resources by leveraging basically a metering capability. So again, back to the topic, cloud characteristics. Cloud computing offers several key characteristics, and that's what I just covered. Okay, so let's look into common deployment models. You have, and I kind of talked about that a little bit, you have infrastructure as a service, platform as a service, and then software as a service. Again, kind of covering those pillars here. Public cloud, these services are offered over the public internet and available to anyone who wants to purchase them. Example, AWS and Google Cloud. That's for public. Private cloud infrastructure operates solely for a single organization, can be managed internally or by a third party. Hybrid cloud combines both public and private cloud, allowing data and applications to be shared between them. So, common cloud deployment models. Infrastructure as a service provides that virtualization where computing resources over the internet are shared. It offers an essential infrastructure such as virtual machines, storage, and networking. It's going to allow the business to scale up and scale down. Users have control over the operating systems and application, making infrastructure as a service an ideal for diverse and dynamic workload. So again, here's an example. You have your data structure, you have equipment, you have virtualization, etc. Software as a service, let's look at that. So software as a service really delivers software applications over the internet on a subscription model, which we all sign up for in some form or fashion. Users access software via web browsers with the server providers managing the infrastructure, platform, and software. SaaS, which is known again as software as a service, eliminates the need for installation and maintenance, offering convenience, cost savings for business of all sizes. Again, if you think of gaming nowadays, that is also more like a software as a service. A lot of applications now is a subscription model. The day of actually getting a CD and some of those things are really over. Platform as a service provides that framework for developers to build and test and deploy application. It includes infrastructure, runtime environments, deployment tools, enabling faster development life cycles. Again, platform as a service abstracts the underlying infrastructure. It really allows developers to focus on coding, innovation, without worrying about hardware or software maintenance. Again, as a previous developer, this is really great. I'm able to spin up an environment that I need, spin up all the attributes needed for my code, and then when I'm done with it, just bring it down, and again, no cost. And then I could And I could do that in different environments, different OSs if I needed to get that done. Again, so this is this platform as a service as an example. So desktop virtualization, it's going to enable users to run a desktop environment from a centralized server. Provides flexibility in assessing a consistent desktop experience from any device. So again, this really allows for anyone to really just um, have a software running somewhere else without necessarily having to upgrade their hardware or software. It's just running the desktop as a virtualization. A cloud storage model that I'm moving on to cloud file storage. So a cloud storage model that provides access to files and data over the internet. Again, example, I think everybody gets this Google Drive and Dropbox. That kind of says it all. It's going to allow for sharing, collaboration, as well as remote access from there. Software-defined networking, so SDN. So an approach to networking that allows users software-based controllers or application program interface. APIs to direct traffic on the network and provide more flexibility, efficient network management. This decouples the control plane from a data plane, allowing for more agile and programmable network configuration. Again, here's an example. You have software on the application, you have the control plane, then the data plane, and then you have pools of applications from that. Again, from an exam perspective, just remember those concepts. Okay, so what are hypervisors and their different types? Again, I kind of covered it a little bit before. So hypervisors are software that create and manage virtual machines, VMs, on a host system, enabling multiple operating systems to run simultaneously on a single physical machine by parsing out the system resources. The two types of hypervisors are type 1 and type 2. Again, type 1 installs directly on the hardware, providing high performance and efficiency. That's a big distinction. Type 2, which is hosted, runs on a conventional operating system suitable for a desktop or a lightweight server virtualization. Again, just remember those concepts from an exam perspective. All right, what does client-side virtualization enhance user productivity and system security? So how, not what. How does client-side virtualization enhance user productivity and system security? So again, client-side virtualization allows users to run multiple virtual machines on their personal device. This capability enables testing application across different operating systems or isolated work environments without needing additional hardware. By maintaining a separate virtual environment, client-side virtualization enhances user productivity and system security as it prevents interface between different applications and protects against malware or system crashes affecting the primary operating system. What is container virtualization, and how does it differ from traditional virtual machine? Container virtualization involves encapsulating applications and their dependency into containers, which share the host system's kernel, making them lightweight and efficient. Unlike traditional virtual machines, which require a separate operating system for each VM, containers utilize the same OS kernel, leading to a faster performance, reduces overhead. This approach ensures consistent performance, which is key, across different environments. It streamlines the application deployment and it's going to enhance scalability. What are the essential security requirements for virtualization? Virtualization introduces several security considerations that must be addressed to ensure a secure, efficient environment. Guest OS security, involves protecting the operating system within VMs through regular updates, patch management, and strong authentication mechanisms. Host security focuses on safeguarding the physical security machine, hosting those VMs by hardening the OS, monitoring for suspicious activity, and implementing robust access control. Hypervisor security is critical as it manages multiple VMs in a host, requiring secure configuration, patches, and restricted access to prevent unauthorized access and potential exploitation. Again, please remember these definitions from a test perspective. What is cloud file security and how does it enhance collaboration? Again, I use Dropbox, Google Drive as an example. So most people are familiar with that. The definition that I have here for an answer is cloud file storage is a cloud storage model that provides access to files and data over the internet, allowing for easy sharing, collaboration, and remote access. Examples include, as I said before, Dropbox, Google Drive. This model enhances collaboration by allowing multiple users to access and edit files simultaneously, facilitating real-time collaboration and, more important, version control. It also provides secure access to files from any device with an internet connection, ensuring that users can work on documents from anywhere. Additionally, cloud file storage often includes features such as automatic backups, file synchronization, further enhancing its utility for collaborative work. So that's just kind of the definition there. Glossary of terms, like I said, I don't cover. You should study these, understand them. What is the definition of cloud-side virtualization, application virtualization, virtualization resource requirement? I covered that. Broad network access, public cloud, platform as a service, cloud file as a service. Again, please study these accordingly. All right, thank you as always. We'll move on to the next chapter and lesson tomorrow. Again, you could take these in sequential order. I think this is information overload. I recommend you take a chapter chapter a day. So go through every day, do the videos, look at the training deck, take a practice test, go back to anything. If you want further coaching one-on-one, please reach out to me. Also read the ebook that I wrote to accompany this. See if that also resonates. Again, I think that's it for now. I will move on.